So this is 122. This is the second meeting. All the previous meeting is here in videos on my page. And let's carry on with chapter 2 here. Now I have somewhere an Opera page all ready to go. Here we go. I just prefer to use a different browser for Google Colab. There's not necessary, but I got enough different things going on. I use different browsers for different purposes. So let me close some unnecessary extra tabs here. And so if you go to the course, here's the free textbook. And if you go there, you can run the notebooks here to run them in Colab. And that's what I've done here, which is the nicest way to get benefit from these books. And there, I got to move this out of the way. Let's close that, I guess. All right, there we are. All right, so the first block of code you run just to prepare it. And then you can go down here. So we're going to talk about variables and statements. Python is a strongly typed language, but it is dynamically typed. They say it's determined at runtime. So if you don't tell it what n is, it will decide what n is by what value you put in there. So when you assign n to be 17, it's an assignment there. And notice it didn't print anything. Now, if you want to print anything, you could just put an n on the line separately, and then it'll print the value. Or you could put print around it, and depending on the kind of environment you're in, you might have to put print around it. In this interactive environment, just putting a variable on the line will generally print it out. And we can also see what type it is. Type of n. All right. And it's an integer, of course. I point it to 17. Now, if I put a decimal point here, I think that'll be enough to make it float. It is. Now it's 17.0 afloat. All right. And just for completeness, if you put quotes around it, then it's a string. Looks just the same, but it's really a string, and so you can't add more to it or multiply it or anything. So here's pi, a floating point variable, and here's a string, message equals something, and so that's, you put the message on a line, it'll print it out, and you can combine it. You can take n plus 25, and it's going to complain because I changed the n into a non-integer here. Let me take this back to what it was, where n was 17, there. And now I'll be able to calculate n plus 25 to get to 42. And 2 pi to get to 6.28. And you can round pi, and by default it'll round it to the integer, no decimal places. If you put a comma here, you can see how many places you want it to be. So rounding it to 2 places will give you 3.14. And here's the length of a string, so that's going to be 42. All right. And you can write diagrams like you see here, where n arrow 17, pi arrow that. That's one way to express these things if you write down notes. So in general, you can use any variable name you like, but there are a few rules. You can't have embedded spaces or punctuation marks. You can have letters and numbers and underscores, but you can't have exclamation points like they have here. Million bang is not acceptable, an invalid syntax. But you could have million underscore 1, and that would be acceptable. 76 trombones is illegal because you can't start with a number. You have to start with a letter. You can have numbers inside, but not at the start. And there are some reserved words, as you can see here, about 20 or 30 of that you can't use. Things like class or import or false or true or things like that. And so here you try to find a variable called class. Notice here, million1 is just white print in Google Colab. That's indicating it's a variable available for you to use. This is blue. That indicates it's a special word with a meaning in Python, and you can't redefine it to be something else. Class means something special, so it's invalid. But if you were to make it class 1, for example, now it turns white, and now it's okay. Because it's just these exact words that are reserved. And you can tell because it changes color. If you want to use libraries, you import them, like import math. If you do it this way, import math, then you'll have access to all the math functions, but you'll have to refer to them this way, like math.py. That gives you this value. Now you could do this from math, I gotta spell it right, from math import pi. And if you did that, then you could just type pi on in here. And there. Now you get, this is the way you import just one symbol, and you don't have to have the math dot in front of it. All right. Anyway, I'm going to go back to import math just so the rest of this notebook will work out as expected. There. All right. And so you have math.square root. You can take math.square root of 25. Notice it's a floating point 5, even though you could do that with an integer. Is this a Python class? No, this is not. This is a Python class at Los Medanos College. So you're welcome to sit in, but you won't get City College credit. You'd have to register at Los Medanos if you want to get credit for it. Anyway, all right, and so pow raises a number to the power of second number, so this is going to take 5 squared, math.pow, and again, it's a floating point value. Even though you could think you could do it as an integer value, these math functions do put out floating point values. All right, by the way, you could also do that another way. You could do 5 star star 2, and that one actually gives you the integer value, print. So that's one difference. I mean, you can do math both ways, but it is sort of interesting. Let me print both of these. There. And so the first one is a floating point 25. The next one is an integer 25. So this method understands that they're integers. This one doesn't, which is kind of interesting. All right. Then you can, of course, combine them. You can have 19 plus n plus round math pi times 2, and so on. All right, so a statement is code that assigns something. If you assign n equals 17, it'll put that in the variable n, and it doesn't print anything out because you didn't tell it to print it or anything. So it works, and it gives you that check mark to show that it works, but there's no output. Import also runs, but it doesn't have any output. It just imports that math function, so it's available. If you put one expression just on a line in an interactive Python environment like this, it will automatically print. If you're in a batch mode where you're saving a file and running a file, you really have to explicitly put in the word print, or at least I always have. I don't think you can just put it on a line like this and see it. And one thing that I just learned while preparing for today's lecture is if you do 2 of these, it only prints the last one this way. That's why, I've never done this nonsense where you just put a variable on a line and expect it to print. I always put in an explicit print. And as I showed you before, if you do that, then it will print. Then there's no question. So I don't know about this, just putting a variable on a line to see the value. That seems like a sort of sleazy thing to do. Anyway, that's how you do it. All right, and of course you can print anything. You can print strings, you can print floating points. It's fine. You can print a sequence of things. I can print a string, comma, then a floating point. And I often do this when I'm trying to print out the value of variables for debugging. I just print out words and variables without concern for type because I can see them there. Notice if you don't specify a format string, you get it in a sort of unfriendly form that can be unnecessarily long, but it's enough to check the value of something. All right. Now functions have arguments. That's what they call them. It's a mathematical term. So if I have the integer function, this is the argument. It's going to take this string and evaluate it as an integer. And if you just do this, it's going to turn the string 101 into the integer 101, so you can do math on it. And as I mentioned before, I spend a lot of my time in Python moving data from one variable type to another. It's often, you have to move integers to strings and strings to integers and floating point back and forth. Math.pow takes 2 numbers, and you can't run it with just one. If you run it with just one, it's going to be an error. You expected 2 arguments, but only got 1. You can take additional arguments, and Wnt 101 can have an optional second argument. If you don't have a second argument, it assumes you're in base 10. Otherwise, you can be in a different base here. So here's binary. That's 5. You could also do octal, base 8. And that's where this is the number of 1s, that's the number of 8s, and this is the number of 64s, so that's going to be 65. Anyway, but if you don't put another number there, it assumes 10, and then this is going to be 101. You can round MathPy, and as I showed, you can round it. If you don't put a second number in, you get it rounded to the nearest integer. If you put in a number, you get that many decimal places after the period, the decimal point. And print, of course, can take any number of arguments. Yeah, all right. If you have too many arguments, like if I do a float of 123, there's no way to have another number here, then it's going to give me a type error. I expected it one argument, but got two. So these error messages are pretty friendly and helpful. All right. And if you provide too few arguments, we've been there, there's also a type error. We saw this one. And if you provide an argument with the wrong type, like if I try to take the square root of the string 123, it can't take the square root of a string. It must be real number, not string. That means you have to get rid of those apostrophes. Now it's a number. Now you can take the square root of it. All right. And are the chapter quizzes supposed to be due before or after? Before is the idea. I don't think we have a late penalty on them, but the idea is you should take them before the lecture. That makes it better. Then you've already been through it once. That's the idea. Good. And if you're doing late, always do stuff even if it's late. But that's what I recommend, is doing it before the lecture. Find out that works better. Anyway, so you can put comments in. You can put a pound at the start of a line, and then this whole green line will be ignored. You can put anything you want there, and you can describe what's happening here. Number of seconds in 42 minutes and 42 seconds. You can also put a pound and put the number over here, or the comment over here. And for good stylistic style in programming, it's good to have comments to guide you. There are several different philosophies here. Some companies actually have very strict commenting rules, and they force you to write code a certain way so other people can, understand it. Other people say forget comments, instead just use descriptive variable names so your code is self-documenting. There's different philosophies different companies use here. But anyway, this is how you put in comments if you want to. And you can debug errors. You just see three types of errors. Syntax errors means your program is so broken it won't run at all. You have a command in there it can't understand. Like if I put in here, this sets v equal 8, and if I try to print it, and I misspell print, then I've tried to call a print t function that doesn't exist, and it's not even going to run. It's going to say, I don't know what you mean with this print t. If it can't understand one of the lines, that's a syntax error and it won't run at all. Then there's a runtime error, which means it runs, but then something goes wrong while it's running. So it's not like this bad where something is spelled wrong as much as it's something under certain conditions, like you divide by something and sometimes it's 0, that sort of thing. And then there's semantic errors, which are what I've generally heard called logic errors, where the computer understands it and it runs without crashing, but it doesn't accomplish your goal because you didn't write the program correctly. And the computer and the debugger can't really help you with that because it doesn't know what you were trying to do. So here, there's a syntax error, or you're using any illegal name. Here's trying to divide a string by a number. That's a runtime error. All right. And here's a logic error. I wanted the average of 1 and 3, but I forgot to put in the parentheses. The average of 1 and 3 is 2, but this answer is not 2. What I really wanted was this. And like I say, the computer can't tell you meant that. It does what you, it doesn't give the right answer. That's a logic error. All right. Anyway, so that's a summary. That's what we've been through for the new stuff here. And let's try a Kahoot. I should have those in my other browser here. All right. And log in. All right. And you got this class, and this is chapter 2. So here we are. All right. So go to kahoot.it and put in that number, and you can play this game and earn extra credit points if you're one of the top scorers. Well, there's not much competition with only one player. On the Jupyter Notebook, I'm wondering what that actually is. If you make your own Jupyter Notebook, you can save those on your own system. If you use Google Cloud, like I do, that's a Jupyter Notebook, and you save it, it goes in your Google account. So I hope that answers your question. Yeah, if you made your own Jupyter Notebook, like with this project here, then it will be storing it all locally, not in the cloud. Absolutely. All right. A bunch of people have vanished. Maybe we're only going to have one person here. I'll go through it anyway. You'll win. And this way people... Oh, good. Okay, anyway. I'll wait a little while to see if anybody else wants to join. If there's only 3 people, you'll all get extra credit for participating. That's fine. And I continue with the questions even when there's no actual competition, so people that view the video can see the review questions. I'll just wait till the end of the song. All right. So, all right, which of these is valid? All right. I guess it should be which of these is not valid. They're all valid except for one. A defect in my question, but there's only one that stands out as invalid, and it's... Oh, you got it right. All right, let me understand. Oh, wait a minute. I'm catching on. This one's not valid because that's not a real library. This, though, I don't see what's wrong with this one. This one is definitely wrong. Well, I'm confused. I don't understand that question myself. I'm going to make a note to review that question. Chapter 2, Kahoot 1. I think there's some kind of mistake in that question, and this is part of why these things are extra credit. Anyway, you're all going to get points today for doing it, but I don't like that question much. It seems to me like this one's perfectly valid, and that one is perfectly valid. This one isn't, but not for good reason. Anyway, let's see if the next questions make more sense. That one wasn't much good. All right. Which of these is invalid? That makes more sense. Okay, good. One of these is invalid. And I think the previous one should also have said one is invalid. Okay. Pass is like class? Is it? That's an interesting thing you say. I wonder if that's true. Pass is a reserved word. I don't know that. And I certainly didn't memorize them all. Is pass forbidden? It is. Why, you're right. Okay. So maybe that question is correct. Pass was wrong and pi... Okay, but that's a little tough. All right, anyway, good. I'm glad you brought it. Now, this one here is invalid. The invalid one is this one, because you're taking something to the power, a number, but you don't have a second number. This is the one that's invalid. This is valid. This is going to interpret 111 as base 3, which is going to be 1 plus 3 plus 9. And this is going to take the square root of 50, and this is going to take 2 to the second power. This is going to take pi to the undefined power and give you an error message. All right, anyway. All right. And what's that? 1 plus 2 star 3. That's 7, because multiplication happens before addition, something they like to tell you in beginning programming classes. So this is 6 plus 1 for 7. Like I say, I prefer to add parentheses around it to make it 100% clear, but technically it's 7. Now I don't know how anybody would get, if you added first and then multiplied, you'd get 9. And that's what had happened if you had parentheses around the 1 plus 2. But without parentheses, multiplication happens before addition. All right. Fair enough. Anyway, so you're both going to win. Now you're getting these names. Fat Bunny will have to tell me who they really are if they want their points. And Ethan, that looks like a real name, however. Ethan will get his 3 points. Fat Bunny, maybe if we know who Fat Bunny is or if they tell me who they are. All right, so that's the lecture and the Kahoots. Let me stop this recording.